We've all seen lightning. I guess lightning is just a huge release of electricity, isn't it?
That's right. Scientists don't even know exactly how it begins, but for some reason the clouds become enormously charged. There's a rubbing together, much like our rubbing of plastic and fur, rubbing of the particles inside the cloud. So we get a big surplus of negative charge on the underside of the cloud. Then that pulls on the positive charges in the atoms of air underneath, pushes on the negative charges, and if there's enough charge on the cloud, it pulls some negative charges off the atoms. We're left then with atoms that have a surplus of positive charge, and those positive charges and negative charges start moving. They bump into other atoms, knock them apart, and so very quickly we have lots of positive charges moving up, negative charges moving down, and all that motion heats the air to thousands of degrees, so that two things happen. First, the air is so hot that it glows brilliantly, and that produces the light that we call lightning. And second, the pressure of the air goes very high, and then it explodes outwards. And that produces the sound that we call thunder, which of course we hear later because sound travels much more slowly than light.
Since the subject is lightning, I'm assuming this is a lightning maker.
That's right. This is called a Tesla coil, and it's quite like our Van de Graaff machine. It'll put an enormous electric charge on this ball at the top so that it becomes our lightning, our thunder cloud, and when we turn it on, we'll get lightning going out from it in all directions. Now, if I were a tall human being standing in an empty field, then unfortunately the lightning always picks the path of least resistance, so it would pick me, and we'd see the lightning discharge going to me. Here we go. On the other hand, if you would like to act, Larry, as a lightning rod, bring up a metal rod to it, and the lightning will pick it as its route, and it'll save me from being struck.